8th grade, Unit 1, Lesson 1, Moving in the Plane. Number 1. The 6 frames show a shape's different positions. Describe how the shape moves to get from its position in each frame to the next. From frame 1 to frame 2, the shape moves up vertically. From frame 2 to frame 3, the shape rotates 90 degrees counterclockwise. Moving from frame 3 to frame 4, the shape drops straight down vertically, then moves right horizontally. From frame 4 to frame 5, the shape rotates 90 degrees clockwise. From frame 5 to frame 6, the shape moves horizontally to the left. Number 2. These 5 frames show a shape's different positions. Describe how the shape moves to get from its position in each frame to the next. From frame 1 to frame 2, the shape moves to the right horizontally. From frame 2 to frame 3, the shape rotated 90 degrees clockwise. From frame 3 to frame 4, the shape moved down vertically. From frame 4 to frame 5, the shape rotated 180 degrees. Number 3. Diego started with this shape. Diego moves the shape down, turns it 90 degrees clockwise, then moves the shape to the right. Draw the location of the shape after each move. Here's a look at the location of the shape after each of the 3 moves. You can show your support for my YouTube channel by liking this video, leaving a comment, and subscribing to my channel. Thanks, I really appreciate it. See you next time. 8th grade, Unit 1, Lesson 2, Naming the Moves. Number 1. Each of the 6 cards shows a shape. A. Which pair of cards shows the shape and its image after a rotation? Look at the shape on card 1. After a 90-degree rotation counterclockwise, the shape matches card 4. Cards 1 and 4 show a shape and its image after a rotation. B. Which pair of cards shows a shape and its image after a reflection? Which pair of cards show a shape and its image after a reflection? Take a look at cards 5 and 3. The shape on card 5 is a mirror image of the shape on card 3. Cards 3 and 5 show the shape and its image after a reflection. Number 2. The 5 frames show a shape's different positions. Describe how the shape moves to get from its position in each frame to the next. For the shape to get from its frame 1 position to its frame 2 position, it moves to the right. For the shape to get from the frame 2 position to the frame 3 position, it moves up, then it rotates 180 degrees. For the shape to get from the frame 3 position to the frame 4 position, the shape moves to the left. And finally, for the shape to get from the frame 4 position to the frame 5 position, it moves down and rotates 180 degrees. Number 3. The rectangle seen in frame 1 is rotated to a new position seen in frame 2. Select all the ways the rectangle could have been rotated to get from frame 1 to frame 2. The rectangle in frame 1 can be rotated 40 degrees counterclockwise to get from frame 1 to frame 2. And the rectangle in frame 1 can also be rotated 140 degrees clockwise to get from frame 1 to frame 2. In this example, I've rotated the rectangle 180 degrees, a little bit too far, but if we back it up 40 degrees, it lines up perfectly. 180 degrees minus 40 degrees is 140 degrees. Here you can see the rotation of 140 degrees clockwise. You can show your support for my YouTube channel by liking this video, leaving a comment, and subscribing to my channel. Thanks, I really appreciate it. See you next time. Unit 1, Lesson 3, Grid Moves. Number 1, apply each transformation described to figure A. If you get stuck, try using tracing paper. A translation which takes P to P prime. This translation takes figure A from P to P prime. B, a counterclockwise rotation of A using center P of 60 degrees. This is the new location for figure A after a counterclockwise rotation of 60 degrees. C, a reflection of A across line L, the line of reflection. Here's a look at the reflection of figure A across line L, or on the other side of the reflection line. If you were to look at it with the reflection line vertical, it would look more like a reflection. Here's an example of that. With the reflection line held vertical, it's easier to see the reflection in this case. Number 2. Here is triangle ABC drawn on a grid. On the grid, draw a rotation of the triangle ABC. I'm going to make a 90-degree rotation, and I'm going to set this up by first making a square. Then I'm going to chip away at the sides that I'm not going to use, and I've taken line AB and redrawn it with a 90-degree angle or a 90-degree rotation. I'll repeat that procedure with line AC. I'll start with a square so that I have a 90-degree angle, and I'll eliminate the sides that I'm not going to need, and I've moved line AC to its new location, which is a 90-degree rotation. The last line is the simplest. I'm just connecting the end of line C with the end of line A, and that gives me line BC. The rotation is a 90-degree clockwise rotation with point A at the center. Draw a translation of triangle ABC. I'm going to start by coloring in point A with the color red, and I'm going to make the translation 4 units down and 3 units across, and I'll place the new red point at that location to represent point A. Let's double check that it's 4 units down and 3 units to the left. Now I'll repeat that process with point B, 4 units down and 3 units to the left, and I'll place the new point for point B. Finally, I'll repeat the process for point C, 4 units down and 3 units to the left, and put the new location for point C. Here's a look at all 3 points. And here's a look at the translation of triangle ABC. The translation of triangle ABC is 4 units down and 3 units to the left. Draw a reflection of triangle ABC. First, I've drawn a horizontal line, the line of reflection. Since point A is 2 units above that line, I'm going to put the reflection point for point A 2 units below the line. I'll do the same for B. B is 1 point above the line, so I'll place B 1 point below the line, and C is 3 points above the line, so I'll place point C 3 points below the line for the reflection. Here's a look at the reflection with all 3 sides to the triangle. The reflection is drawn across a horizontal line of reflection. Number 3A. Draw the translated image of ABCDE so that vertex C comes to vertex C prime. You'd be better off using tracing paper, but I'm putting my example on graph paper. Here's the translated image of A, B, C, D, E with the vertex C moving to C prime. 3b. Draw the reflected image of the pentagon A, B, C, D, E with line of reflection L. Tracing paper may be useful. Since point A is 8 units from the line to the left on the original figure, I'm going to put point A 8 units to the right of the line for the reflection. And I'll use that same strategy for finding the locations of the points for the reflection of the original figure. Now that we have all the points for the reflection, we can fill in the lines and you can see the reflection. The reflection is on the right, the original figure is on the left. 3c. Draw the rotation of pentagon A, B, C, D, E around C clockwise by an angle of 150 degrees. Tracing paper and a protractor may be useful. Here's a look at my final drawing of the rotation of the pentagon. A protractor would really be helpful because you need to find the angle of 150 degrees. Take a look at the original point A that goes to point C, and then from point C to point A on the rotation, you can tell that that's a 150 degree angle if you line up a protractor. When I remove all the other lines around it, you can tell that the angle A, B, A prime is 150 degrees. Again, if you were to line up a protractor, you'd be able to tell that the angle of rotation in this case was 150 degrees. You can show your support for my YouTube channel by liking this video, leaving a comment, and subscribing to my channel. Thanks, I really appreciate it. See you next time. Unit 1, Lesson 4, Making the Moves. Number 1. For each pair of polygons, describe the sequence of translations, rotations, and reflections that takes polygon P to polygon Q. Line AB of polygon P is represented by line HE from polygon Q. Here I'm highlighting the angle of line AB and line HE so you can see how different they are. This angle drawn in purple represents the rotation made going from P to Q. It's a 60-degree angle. A is translated to H with a 60-degree rotation, center H. B, reflected over line AE. A is translated to F, and a 60-degree clockwise rotation with center F. Number 2, here is quadrilateral ABCD and line L. Draw the image of quadrilateral ABCD after reflecting it across line L. Here's a look at the image after it was reflected across line L. C. A is translated to E. 90-degree rotation with center E. Reflected over line EF. Number 3. Here is quadrilateral ABCD. Draw the image of quadrilateral ABCD after each rotation using B as center. A, 90 degrees clockwise. Here's a look at the image after a 90-degree clockwise rotation. I can draw a square inside here to show you that this is a 90-degree angle because squares are made up of 4 90-degree angles. B, 120 degrees clockwise. Here's a look at 120-degree rotation using B as the center. C, 30 degrees counterclockwise. Here's a look at the quadrilateral after a 30-degree counterclockwise rotation. You can show your support for my YouTube channel by liking this video, leaving a comment, and subscribing to my channel. Thanks, I really appreciate it. See you next time. 8th grade, Unit 1, Lesson 5, Coordinate Moves. Number 1. Here are some points. What are the coordinates of A, B, and C after a translation to the right by 4 units and up 1 unit? Plot these points on the grid and label them A', B', and C'. Here's point A', located 4 units to the right and 1 unit up from the original point A. The coordinates for point A' are -2 and 6. Here are points B' and C'. The coordinates for B' are 7 and 3, and the coordinates for C' are 4 and 0. B. Here are some points. What are the coordinates of D, E, and F after a reflection over the y-axis? Plot these points on the grid and label them D', E', and F'. Here's the point for D', and its coordinates are 3 and 3. In green, you see the point for E', and its coordinates are -5 and 0, and at the bottom in purple are the coordinates for the point F'. Its coordinates are -2 and -2. C. What are the coordinates of G, H, and I after a rotation about coordinates 0 and 0 by 90 degrees clockwise? Plot these points on the grid and label them G', H', and I'. After the rotation, the coordinates for G' are 3 and 1. And after the rotation of H, the H' coordinates are 0 and 4. And after the rotation of I, the I' coordinates are -2 and -3. Number 2. Describe a sequence of transformations that takes trapezoid A to trapezoid B. The first move in the sequence, trapezoid A, translates up. In the next move of the sequence, it rotates 60 degrees counterclockwise with the bottom vertex as the center of rotation. The last move is figure A translates left. Number 3. Reflect polygon P using line L. The red figure is the reflection of polygon P using line L. It's like a mirror image. You can show your support for my YouTube channel by liking this video, leaving a comment, and subscribing to my channel. Thanks, I really appreciate it. See you next time. 8th grade, Unit 1, Lesson 6, Describing Transformations. Number 1. Here is trapezoid A in the coordinate plane. A. Draw polygon B, the image of A, using the y-axis as the line of reflection. Here I've drawn polygon B, the image of A, and I've used the y-axis as the line of reflection. B. Draw polygon C, the image of B, using the x-axis as the line of reflection. In green, I've drawn polygon C. It's the image of polygon B, and I use the x-axis as the line of reflection. C. Draw polygon D, the image of C, using the x-axis as the line of reflection. Here you can see I've drawn polygon D in red. It's the exact same shape as polygon B. Number 2. The point -4 and 1 is rotated 180 degrees counterclockwise using center -3 and 0. What are the coordinates of the image? This red point has the coordinates -4 and 1, and this purple point has the coordinates -3 and 0. Rotating 180 degrees counterclockwise using the purple point as the center, the new coordinate would be -2 and -1. After the rotation, the point would have the new coordinates -2 and -1, so the answer would be C. Number 3. Describe a sequence of transformations for which triangle B is the image of triangle A. The first sequence in the transformation would be a translation 2 units to the left and up 2 units. And the final transformation in the sequence is a reflection over the y-axis. Number 4. Here is quadrilateral ABCD. Draw the image of quadrilateral ABCD after each transformation. A. The translation that takes B to D. The image moved to the left so that B lines up with D. B. The reflection over segment BC. The image shares segment BC with ABCD. C. The rotation about point A by angle DAB counterclockwise. The image is rotated so that the side corresponding to AD is now part of segment AB. You can show your support for my YouTube channel by liking this video, leaving a comment, and subscribing to my channel. Thanks, I really appreciate it. See you next time. 8th grade, Unit 1, Lesson 7. No bending or stretching. Number 1. Is there a rigid transformation taking rhombus P to rhombus Q? Explain how you know. Notice the corresponding angles in red and the corresponding angles in green. They're different measures. No, the angle measures of the two polygons are not the same. A rigid transformation would maintain the same angles and lengths. And since these angles are different, a rigid transformation did not take rhombus P to rhombus Q. Number 2. Describe a rigid transformation that takes triangle A to triangle B. Let's start by looking at this point, located on the bottom right corner of triangle A. The coordinates are 3 and 0. The corresponding coordinates on triangle B are 6 and 2. The rigid transformation is 3 units to the right and 2 units up. Number 3. Is there a rigid transformation taking rectangle A to rectangle B? Explain how you know. First, take a look at the corresponding lengths in green and the corresponding lengths in red. There is no rigid transformation taking place because the side lengths of the two rectangles are not the same. A rigid transformation would maintain all lengths and all angle measures. Number 4. For each shape, draw its image after performing the transformation. If you get stuck, consider using tracing paper. A. Translate the shape so that A goes to A prime. Translated from A to A prime, the image of the shape is represented in green. B. Rotate the shape 180 degrees counterclockwise around B. Represented in red, you can see the new location after a 180 degrees counterclockwise rotation. C. Reflect the shape over the line shown. Represented in red is the reflection of the original shape. You can show your support for my YouTube channel by liking this video, leaving a comment, and subscribing to my channel. Thanks, I really appreciate it. See you next time. 8th grade, Unit 1, Lesson 8, Rotation Patterns. Number 1. For the figure shown here, A. Rotate segment CD 180 degrees around point D. With point D as the center, rotate segment CD around point D. The segment is attached at point D and is an extension of segment CD. B. Rotate segment CD 180 degrees around point E. With point E as the center, rotate segment CD 180 degrees. The segment is above point E and is parallel to segment CD. C. Rotate segment CD 180 degrees around point M. Using point M as the center, rotate segment CD 180 degrees. The segment is identical to segment CD, only the endpoints have switched locations. Number 2. Here's an isosceles right triangle. Draw these 3 rotations of triangle ABC together. A. Rotate triangle ABC 90 degrees clockwise around A. Here's a look at the 90-degree clockwise rotation using A as the center. B. Rotate triangle ABC 180 degrees around A. In green, you'll see the 180-degree rotation using point A as center. C. Rotate triangle ABC 270 degrees clockwise around A. In red, you'll see the triangle's 270 degrees clockwise rotation around point A as the center. Number 3. Each graph shows 2 polygons, ABCD and A', B', C', and D'. In each case, describe a sequence of transformations that takes A, B, C, D to A', B', C', D'. To get from the first polygon to the second polygon, I would reflect ABCD over the y-axis and then translate down 1. B. To get from the first polygon to the second polygon, I would rotate ABCD 90 degrees clockwise with center B equaling coordinates -1 and 0, and then translate coordinates -1, 0 to coordinates 3 and 1. Number 4. Lynn says that she can map polygon A to polygon B using only reflections. Do you agree with Lynn? Explain your reasoning. I agree. Polygon A can be reflected over the vertical line L, then over the horizontal line M to get from polygon A to polygon B. Here's a look at the 2 reflections that take polygon A to polygon B. You can show your support for my YouTube channel by liking this video, leaving a comment, and subscribing to my channel. Thanks, I really appreciate it. See you next time. 8th grade, Unit 1, Lesson 9, Moves in Parallel. Number 1. A. Draw parallel lines AB and CD. B. Pick any point E, rotate AB 90 degrees clockwise around E. C. Rotate CD 90 degrees clockwise around E. D. What do you notice? I notice that the new lines are still parallel after the rotation. Number 2. Use the diagram to find the measures of each angle. Explain your reasoning. A. What is the measure of angle ABC? I've highlighted angle ABC in blue and I've highlighted 50 degrees in red. I know that vertical angles or opposite angles share the same vertex and their angle measures are equal. So opposite 50 degrees will be another angle of 50 degrees. Angle EBC will total 180 degrees, and I know that angle ABE is 50 degrees, so the remainder is 130 degrees. Angle ABC measures 130 degrees. B. What is the measure of angle EBD? Well, you can see angle EBD in green, and again 130 degrees plus 50 degrees equals 180 degrees, so angle EBD measures 130 degrees. C. What is the measure for angle ABE? Highlighted in a reddish color, angle ABE is 50 degrees. Again, 50 degrees plus 130 degrees equals 180 degrees. The measure of angle ABE is 50 degrees. Here's another look at 180 degrees. This angle measures 90 degrees, so another 90 degree angle would total 180 degrees. 90 degrees plus 45 degrees plus another 45 degrees also equals 180 degrees. I used that same strategy here on problem number 2 when they gave me one angle of 50 degrees. I knew that 180 degrees minus 50 degrees equaled 130 degrees, and that's how I found the measure for that larger angle, 130 degrees. Number 3. Points P and Q are plotted on a line. A. Find a point R so that a 180 degree rotation with center R sends P to Q and Q to P. The middle point will be the location for R. It's as if it's the axle and you spin a propeller. Q would go where P is and P would go where Q is. B. Is there more than one point R that works for part A? No, the midpoint is the only point that will work. Number 4. In the picture, triangle A', B', C' is an image of triangle ABC after a rotation. The center of rotation is D. A. What is the length of side B', C'? Explain how you know. The length of side B' and C' will be the same as the length of side BC. I know that their lengths are the same because side B', C' are the corresponding angles to side BC. B. What is the measure of angle B? Explain how you know. The measure of angle B is 52 degrees, and I know that because rotations maintain the same angle measures, and angle B and B' correspond to each other. C. What is the measure of angle C? Explain how you know. The measure of angle C is 50 degrees, and I know this because rotations maintain the same angle measures, and angle C and C' correspond to each other in this rotation. Number 5. The point -4 and 1 is rotated 180 degrees counterclockwise using center 0, 0. What are the coordinates of the image? A key piece of information is the 180 degree counterclockwise rotation using center 0, 0 and the point -4, +1. The center point would be 0, 0, which is where the origin is, right in the middle where these two axes intersect. When you rotate the point -4, +1 180 degrees, it ends up at +4, -1. So the answer would be D. You can show your support for my YouTube channel by liking this video, leaving a comment, and subscribing to my channel. Thanks, I really appreciate it. See you next time. 8th grade, Unit 1, Lesson 10, Composing Figures. Number 1. Here is the design for the flag of Trinidad and Tobago. Describe a sequence of translations, rotations, and reflections that take the lower left triangle to the upper right triangle. A rotation of 180 degrees around the center point of the flag would take you from the triangle on the lower left to the triangle on the upper right. Number 2. Here is a picture of an older version of the flag of Great Britain. There is a rigid transformation that takes triangle 1 to triangle 2, another that takes triangle 1 to triangle 3, and another that takes triangle 1 to triangle 4. A. Measure the lengths of the sides in triangle 1 and 2. What do you notice? Triangles 1 and 2 have equal side lengths. B. What are the side lengths of triangle 3? Explain how you know. Triangle 3 has the same side lengths as triangle 1 because a rigid transformation occurred, taking triangle 1 to triangle 3. C. Do all 8 triangles in the flag have the same area? Explain how you know. No. There are 4 larger triangles that would have larger areas than the smaller triangles. Number 4. A. Which of the lines in the picture is parallel to line L? Explain how you know. K is parallel to line L. These two lines would never intersect, no matter how far they extend. B. Explain how to translate, rotate, or reflect line L to obtain line K. Translating line L would obtain line K. C. Explain how to translate, rotate, or reflect line L to obtain line P. Rotating line L would obtain line P. Number 4. Point A has coordinates 3 and 4. After a translation 4 units left, a reflection across the x-axis, and a translation 2 units down, what are the coordinates of the image? I'm going to start by making a grid with an x-axis and a y-axis. Next, I'm going to place the point at coordinates 3 and 4, or 3 units to the right and 4 units up. The first thing that they asked me to do was a translation 4 units to the left. That means I need to move this point 4 units to the left. There's the new location of the point. Next, they asked to do a reflection across the x-axis. The x-axis is the horizontal axis. It runs left and right. The y-axis is the vertical axis. It runs up and down. So they're asking us to do a reflection across the x-axis. Right now the point is 4 units above the x-axis. We need to put the point as a reflection 4 units below the x-axis. Here's the new location of the point after the reflection across the x-axis. The last step that they're asking us to do is a translation 2 units down. So we need to move the point 2 units down along the y-axis. Here's the final location of the point after all the moves. The coordinates are -1 and -6. At the end they ask, what are the coordinates of the image? -1 and -6 are the coordinates of the point's new location. Number 5. Here is triangle XYZ. Draw these 3 rotations of triangle XYZ together. A. Rotate triangle XYZ 90 degrees clockwise around Z. I put this triangle on graph paper. This black triangle represents the original triangle XYZ. The green triangle represents triangle XYZ after a rotation of 90 degrees. B. Rotate triangle XYZ 180 degrees around Z. I'll draw all the rotations individually first, and then at the end I'll put them all together. The blue triangle represents triangle XYZ after a rotation of 180 degrees. C. Rotate triangle XYZ 270 degrees clockwise around Z. Again, the black triangle represents triangle XYZ. The purple triangle represents triangle XYZ after a 270 degree clockwise rotation around Z. They did ask to draw these 3 rotations of triangle XYZ together, so now I'll put them all together. You can show your support for my YouTube channel by liking this video, leaving a comment, and subscribing to my channel. Thanks, I really appreciate it. See you next time. 8th grade, Unit 1, Lesson 11. What is the same? Number 1. If 2 rectangles have the same perimeter, do they have to be congruent? Explain how you know. I've illustrated 2 rectangles. The first rectangle has a perimeter of 10, and the second rectangle also has a perimeter of 10. Though they have the same perimeter, they're not congruent. The first rectangle has an area of 6 square units, and the second rectangle has an area of 4 square units. So the answer to this question is no. It is possible for 2 non-congruent rectangles to have the same perimeter. Number 2. Draw 2 rectangles that have the same area, but are not congruent. I've drawn these 2 rectangles for my examples. The top rectangle has a base of 10 and a height of 2, and the bottom rectangle has a base of 5 and a height of 4. They're not congruent, but they both have the same area, 20 units squared. Number 3. For each pair of shapes, decide whether or not it appears that the 2 shapes are congruent. Explain your reasoning. These 2 shapes appear congruent. They overlap perfectly, appearing congruent. B. These 2 shapes appear congruent. Reflect the first shape about a vertical line and translate down. It would match perfectly over the second shape. Number 4. A. Reflect quadrilateral A over the x-axis. Label the image quadrilateral B. Reflect quadrilateral B over the y-axis. Label the image C. I'm going to start with image A, and I'm going to reflect it over the x-axis and label this new image B. Next, I'm going to reflect image B across the y-axis and label the new image C. B. Are quadrilaterals A and C congruent? Explain how you know. Yes, they are congruent because a rigid transformation took quadrilateral A to quadrilateral C. Number 5. The point with coordinates -2 and -3 is rotated 90 degrees counterclockwise using center with the coordinates 0 and 0. What are the coordinates of the image? I'm going to start with a graph with an x-axis and a y-axis and place the original point with coordinates -2 and -3. Next, I need to use the center point with coordinates 0 and 0 to rotate counterclockwise 90 degrees. This would take me to the point's new set of coordinates, which would be located at 3 and -2. So the answer would be C, the coordinates 3 and -2. Number 6. Describe a rigid transformation that takes polygon A to polygon B. Whatever it is, this rigid transformation is going to move polygon A to the right and then down to where polygon B is located. You can rotate polygon A 180 degrees around center point coordinates 0, 0 to get to polygon B. Or you can reflect about the y-axis, then a reflection about the x-axis. You can show your support for my YouTube channel by liking this video, leaving a comment, and subscribing to my channel. Thanks, I really appreciate it. See you next time. 8th grade, Unit 1, Lesson 12, Congruent Polygons. Number 1. A. Show that the two pentagons are congruent. Segments DE and FG are the same length, so they're congruent. Segment BC and segment HI are congruent, and segment CD and GH are also the same length, so they're congruent. Here's a look at a 90-degree clockwise rotation with center D, then translating 3 units down and 6 units to the right. It matches up perfectly. B. Find the side lengths of A, B, C, D, E, and the angle measures of F, G, H, I, and J. The side length of AB is 2 2/10. BC is 1 4/10. CD is 3 2/10. DE is 4 1/10, and EA is 2 8/10. Angle F is 59 degrees. Angle G is 94 degrees. Angle H is 117 degrees. Angle I is 108 degrees, and angle J is 162 degrees. Number 2. For each pair of shapes, decide whether or not the two shapes are congruent. Explain your reasoning. A. Line segment CD measures 3 on the first shape, and line segment GH measures 4 on the second shape, yet line segments BC and FG have the same measure. These two shapes are not congruent. Segment HG is longer than segment CD, yet segment FG is equal to segment BC. B. These shapes are congruent. The original shape rotated 90 degrees about C, it moved 4 units to the right, and it moved up 1 unit. C. These two shapes are congruent. The first shape was translated to the right by 8 units and then moved down 3 units. Number 3. A. Draw segment PQ. I drew a line segment and labeled it PQ. B. When PQ is rotated 180 degrees around point R, the resulting segment is the same as PQ. Where would point R be located? So if I rotate this line segment 180 degrees, they would ultimately be switching places. So the Q would be in place of P and the P would be in place of Q. The point of rotation would be in the very middle, so R would be located in the very middle. In this situation, I think of it kind of like a propeller on an airplane, where P and Q would trade places as it's rotated 180 degrees. Number 4. Here is trapezoid ABCD. Using rigid transformations on the trapezoid, build a pattern. Describe some of the rigid transformations you used. I made 2 clockwise rotations centered at the vertex of the 60-degree angle. My first rotation was 90 degrees and my second rotation was 180 degrees. You can show your support for my YouTube channel by liking this video, leaving a comment, and subscribing to my channel. Thanks, I really appreciate it. See you next time. 8th grade, Unit 1, Lesson 13, Congruence. Number 1. Which of these 4 figures are congruent to the top figure? Figure A is not congruent because the distance of the dots are further apart in figure A than they are in the original figure. Figure B appears to be congruent with the original figure. The side lengths, the angles, and the dots all appear to be the same measure as the original figure. Figure C is pretty close, however I think the side lengths might be slightly larger on figure C than they are on the original figure. And figure D is not congruent with the original figure either because the dots on figure D are vertical compared to the dots on the original, which are horizontal. Number 2. These 2 figures are congruent with corresponding points marked. A. Are angles ABC and A'B', C' congruent? Explain your reasoning. I traced over the second congruent figure, leaving A', B', and C' identified with tiny gaps in the tracing. And those tiny gaps in the tracing line up perfectly with angles A, B, and C. So angles A, B, and C and A', B', and C' are congruent. B. Measure angles A, B, C and A', B', C' to check your answer. You can use a protractor to measure these angles, and both of them measure just about 110 degrees. And since they have the same measure, angles A, B, C and angles A', B', C' are congruent. Number 3. Here are 2 figures. Show using measurement that these 2 figures are not congruent. This red marker marks the width of figure A. In comparison to figure B, the red marker is just a little bit wider. This is one way to tell that these 2 figures are not congruent. You could repeat this process with a vertical line showing the height of figure A in comparison to the height of figure B, and the height of figure A would be shorter than the height of figure B. Number 4. Each picture shows two polygons, one labeled polygon A and one labeled polygon B. Describe how to move polygon A into the position of polygon B using a transformation. "180-degree rotation with center point the vertex shared by A and B." Another transformation could be a reflection across the vertical line that runs through the vertex shared by figure A and figure B. B. Rotate figure A clockwise 90 degrees around the vertex shared by the two figures. C. Translate up and then to the right. It goes up 1 unit and to the right 3 units. You can show your support for my YouTube channel by liking this video, leaving a comment, and subscribing to my channel. Thanks, I really appreciate it. See you next time. 8th grade, Unit 1, Lesson 14. Alternate interior angles. Alternate interior angles are created when two parallel lines are crossed by another line called a transversal. Alternate interior angles are inside the parallel lines and on opposite sides of the transversal. This diagram shows two pairs of alternate interior angles. Angles A and D are one pair, and angles B and C are another pair. Transversal. A transversal is a line that cuts across parallel lines. In this example, the transversal line is marked in red. Number 1. Use the diagram to find the measures of each angle. Explain your reasoning. A. The measure of angle ABC. I highlighted the angle ABC in yellow. And they tell us that angle CBD is 50 degrees. Angle ABC plus 50 degrees will equal 180 degrees. So 180 degrees minus 50 degrees will equal the measure for angle ABC. Since 180 minus 50 is 130, angle ABC is 130 degrees. And we can double check that by adding it. 50 degrees plus 130 degrees equals 180 degrees. B. The measure of angle EBD. Well, they started out by giving us the measure for angle CBD, and that was 50 degrees. And the alternate interior angle for CBD is angle ABE, which will also be 50 degrees. And then we figured out the measure for angle ABC, which was 130 degrees. And it has an alternate interior angle as well, and that's angle EBD. So angle EBD's measure will also be 130 degrees. C. The measure of angle ABE. Well, we already found that. The measure for angle ABE will be the alternate interior angle of angle CBD. And that alternate interior angle is ABE. So that will also be 50 degrees. Number 2, lines K and L are parallel, and the measure of angles ABC is 19 degrees. A. Explain why the measure of angle ECF is 19 degrees. If you get stuck, consider translating line L by moving B to C. I highlighted line K in green and line L in red, and you can see that they're parallel. Now I'm highlighting angle ABC in red. They told us that angle ABC is 19 degrees, so that we know that this red angle, ABC, is 19 degrees. Angle ABC and angle ECF are the same measure. If you were to trace them and lay one on top of the other, you would see that they are the same measure. They're both 19 degrees. B. What is the measure of angle BCD? Explain. Angle BCD is an alternate interior angle of angle ECF. And since angle ECF is 19 degrees, then angle BCD will also be 19 degrees. I went ahead and labeled all the angles with the measure of 19 degrees. Number 3. The diagram shows 3 lines with some marked angle measures. Find the missing angle measures marked with question marks. Well, 70 plus the angle labeled with the question mark to its left would total 180 degrees. So 180 degrees minus 70 is 110. So 110 degrees plus 70 degrees would equal 180 degrees. This question mark represents 110 degrees. Now all we have to do is identify the alternate interior angles. First, let's find the alternate interior angle for 110 degrees. There's the alternate interior angle for 110 degrees. Now let's find the alternate interior angle for the angle with the measure of 70 degrees. This question mark represents the alternate interior angle for the angle that is 70 degrees, so it will also be 70 degrees. Now on the other side, this question mark represents the alternate interior angle for the angle marked 53 degrees. We can switch this question mark now to 53 degrees. Now these last 2 question marks, they represent alternate interior angles of each other. In order to find the measurement for those, we need to ask ourselves, what number plus 53 equals 180? That's the same as 180 degrees minus 53 degrees equals 127 degrees. So both of these question marks represent angles with a measure of 127 degrees. And we can double check by adding 127 plus 53. That should equal 180 degrees. We can even add up the total of all 4 of these angles, and that should equal 360 degrees. 53 plus 127 plus 53 and plus another 127 should total 360 degrees. Number 4. The 2 figures are scaled copies of each other. A. What are some ways that you can tell that they are scaled copies? Here's one way to tell that they're scaled copies. Angles A and P are corresponding angles. This line in red above angle A is 1 unit long, and that same line above angle P is 3 units long. That's a ratio of 1 to 3. Angles C and R are also corresponding angles, and the line I've drawn next to angle C is 1 unit, and the line that I've drawn next to angle R is 3 units. That's also a ratio of 1 to 3 units. You can see I've drawn a few more lines. One is 2 units long compared to 6 units long, and another is 3 units long compared to 9 units long. Their ratios are 2 to 6 and 3 to 9. These measurements all prove that all the lines on figure 2 are exactly 3 times longer than the lines on figure 1. And that proves that they are scaled copies. B. What is the scale factor that takes figure 1 to figure 2? The scale factor that takes figure 1 to figure 2 is 3, because figure 2 is 3 times larger than figure 1. C. What is the scale factor that takes figure 2 to figure 1? The scale factor that takes figure 2 to figure 1 is 1/3, because figure 1 is 1/3 the size of figure 2. You can show your support for my YouTube channel by liking this video, leaving a comment, and subscribing to my channel. Thanks, I really appreciate it. See you next time. 8th grade, Unit 1, Lesson 15, Adding the Angles in a Triangle. Here's a glossary term that you should know, a straight angle. A straight angle is an angle that forms a straight line. It measures 180 degrees. Number 1. In triangle ABC, the measure of angle A is 40 degrees. A. Give possible measures for angles B and C if triangle ABC is isosceles. An isosceles triangle is a triangle with at least 2 equal sides. This angle in red would represent angle A of 40 degrees. The bottom angles would represent angles B and C. Since all 3 of the angles in a triangle will total 180 degrees, I can subtract 40 degrees from 180 degrees, and I get 140 degrees, which would be the combined total of angles B and C. 140 degrees divided by 2 is 70, so angles B and C have a measure of 70 degrees. B. Give possible measures for angles B and C if triangle ABC is a right triangle. So in this scenario, the triangle is a right triangle. Here's an example of a right triangle, and one of the angles in the right triangle has a measure of 90 degrees. The other 2 angles would be 40 degrees and 50 degrees, because 90 plus 40 plus 50 equals 180. In this case, angle B is smaller than angle C, so angle B would be the 40 and angle C would be 50. Number 2. For each set of angles, decide if there is a triangle whose angles have these measures in degrees. If you get stuck, consider making a line segment, then use a protractor to measure angles with the first 2 angle measures. A. 60 degrees, 60 degrees, and 60 degrees. Well, 60 plus 60 plus 60 equals 180, or 180 degrees. So the answer would be yes. B. 90 degrees, 90 degrees, and 45 degrees. 90 plus 90 plus 45 is greater than 180 degrees, so this would be no. C. 30 degrees, 40 degrees, and 50 degrees. 30 plus 40 plus 50 is less than 180, so this would be no. D. 90 plus 45 plus 45. 90 plus 45 plus 45 is exactly 180, or 180 degrees, so D would be yes. E. 120 plus 30 plus 30. Well, 120 plus 30 plus 30 is exactly 180, so E would also be yes. Number 3. Angle A in triangle ABC is obtuse. Can angle B or angle C be obtuse? Explain your reasoning. No, it is not possible to have more than one obtuse angle in a triangle. Obtuse angles are greater than 90 degrees, and the sum of all 3 angles must equal 180 degrees. Number 4. For each pair of polygons, describe the transformation that could be applied to polygon A to get to polygon B. A. A translation right 6 units and down 3 units. B. A reflection with a vertical line of reflection halfway between the two polygons. C. A 90-degree counterclockwise rotation with the vertex shared by the two polygons as the rotation's center. Number 5. On the grid, draw a scaled copy of quadrilateral ABCD using a scale factor of 1/2. Well, if we're to use a scale factor of 1/2, that means all the line segments are going to be exactly 1/2 the length of the original copy. You can show your support for my YouTube channel by liking this video, leaving a comment, and subscribing to my channel. Thanks, I really appreciate it. See you next time. 8th grade, Unit 1, Lesson 16, Parallel Lines and the Angles in a Triangle. Number 1. For each triangle, find the measure of the missing angle. The missing angle in Figure 1 is angle C. Angle A is 28 degrees, so 28 degrees plus angle B, or 128 degrees, plus the missing angle C will total 180 degrees. Or we can look at it this way: 180 degrees minus 28 degrees minus 128 degrees will equal the missing angle C. And 180 degrees minus 28 minus 128 equals 24. So the missing angle C has a measure of 24 degrees. The missing angle in Figure 2 is angle D. Angle F is 38 degrees, angle E is 122 degrees, so 38 degrees plus 122 degrees plus angle D will equal 180 degrees. Or 180 degrees minus 38 degrees minus 122 degrees will equal angle D. The measure for angle D is 20 degrees. The missing angle for Figure 3 is angle L. Angle J is 20 degrees, angle K is 72 degrees, so 20 plus 72 plus the unknown value for L would equal 180 degrees. 180 minus 20 minus 72 is 88. So the measure for angle L is 88 degrees. The missing measure for Figure 4 is angle I. I'll leave this for you to finish. Press pause and finish it. The missing angle is 35 degrees. That wasn't too difficult. Number 2. Is there a triangle with two right angles? Explain your reasoning. No. All three angles in a triangle add up to 180 degrees. Two right angles already totals 180 degrees because each right angle is worth 90 degrees, and there wouldn't be any angle left over for the third angle. It would be impossible. Number 3. In this diagram, lines AB and CD are parallel. Angle ABC measures 35 degrees and angle BAC measures 115 degrees. What is the measure of angle ACE? What is the measure of angle DCB? What is the measure of angle ACB? I'm going to go back to the diagram and figure out all the missing angles. Then I'll come back to A, B, and C. They told us that angle ABC had a measure of 35 degrees. So all the corresponding angles will also be 35 degrees. They told us that angle BAC had a measure of 115 degrees. So all the corresponding angles would be 115 degrees. Line ED forms the angle of 180 degrees. 180 minus 35 minus 115 equals 30. So the measure of this missing angle is 30 degrees, and its corresponding angle will also be 30 degrees. To find this missing angle, we can add 35 degrees plus 30 degrees, and that would be 65 degrees. Its corresponding angles would also be 65 degrees. To find this missing angle, 180 degrees minus 35 degrees would give us the missing measure.
the missing measure for the angle would be 145 degrees. Its corresponding angle would also be 145 degrees. It looks like we found all the missing angles, so let's go back and look at A, B, and C. This question can be translated to, what is the measure of angle ACE? Let's go back and look at ACE. Here's angle ACE, and 115 degrees is the measure for angle ACE. B. What is the measure of angle DCB? Well, we have to look for DCB. There's D, there's C, and there's B. So 35 degrees is the missing measure for angle DCB. C. What is the measure for angle ACB? There's A, there's C, and there's B. It looks like somehow I removed the missing measure. The missing measure would be right here, and I know its corresponding measure is 30 degrees, so its measure would be 30 degrees. So the measure of angle ACB is 30 degrees. Number 4. The two figures are congruent. A. Label the points A', B', and C' that corresponds to A, B, and C in the figure on the right. Down on the bottom, we can see point A, and I've labeled its corresponding point A'. And here we have point B, and I've labeled its corresponding point B'. And here we have point C, and I've labeled its corresponding point C'. B. If segment AB measures 2 centimeters, how long is segment A', B'? Explain. 2 centimeters, because the shapes are congruent and corresponding segments of congruent shapes are always congruent. C. The point D is shown in addition to A and C. How can you find the point D' that corresponds to D? Explain your reasoning. Measure the distance from point D up to the end of the straight line. Place point D' that same distance up from the start of the straight line. Here I've labeled the point for D'. You can show your support for my YouTube channel by liking this video, leaving a comment, and subscribing to my channel. Thanks, I really appreciate it. See you next time.